Hi dear children, our 11th chapter, area related to circle. Chapter name is chapter 11, areas related to circles. Area of sector and segment of a circle. Okay. Before starting the problems, we have to discuss some keywords. Already we studied the circle. And actually this chapter is continuation of chapter 10. Sector of a circle. First, sector of a circle. What is the sector of a circle? That is first concept. Okay, the sector of a circle is, suppose this is the center, part of the circular region. Suppose this is AUP. This part, this is sector of a circle. The portion of circular region enclosed by two radii. Here OA and OB are the radii. And the corresponding arc. This arc, corresponding arc. This is called sector. This is called sector. And also, suppose this is ACB. OACB. This is a sector. And this is also a sector. ADBO. This is also, this is the smaller sector. This is the larger sector. Or minor sector or major sector. Minor sector, smaller portion of the circle divided by two radii. That is smaller sector. This big portion, this portion is the major sector. Okay. Next, segment of a circle. Next is, actually it is not sector. Something wrong here. Next is arc of a circle. Arc. Suppose this is a circle. Suppose this is the part of the circumference of a circle. Suppose this is OAB. This part. Suppose this is ACB. This is called arc ACB. And this is also arc ADB. Arc, this is a bigger arc. This is the minor arc ACB. This is the major arc ADB. Here ACB is the minor arc and arc ADB. This arc. This is major arc of the circle. Major arc of the circle. Okay. We can define the minor arc. An arc whose length less than the circumference, less than the half of the circumference is called minor arc. If the arc length is greater than the half of its circumference, it is called major arc. Okay. So you have to identify arc of a circle. What is arc of a circle? That is the part of the circumference of the circle. But sector is what is the sector of a circle? That is a portion or part of the circular region. That is called sector. Okay. Actually, length of this minor arc, that is ACB, plus length of the major arc, that is ADB. Actually, this is the circumference of the circle, total circumference of the circle. The minor arc ACB plus corresponding length of the major arc describes the circumference of the circle. That is very important. And already we studied sector of a circle, major sector, minor sector. Okay, next is angle of a sector. Next is angle of a sector. What is the angle of a sector? Suppose this is the circle, this is the center, these are two radii. Suppose OA and OB are the radii. Suppose this is angle theta. Here the angle theta is called angle of this minor sector. Angle of a sector, the angle formed by the two radii at the center. That is very important. At the center, at the center. Angle of major arc means this is the angle of major arc. This angle. Actually, this is total angle of a circle is 360 degree minus angle of the minor sector. Here in this figure, that is 360 degree minus theta degree is called the angle of the major sector, and theta is the angle of the minor sector. Okay. Next is area of a sector with angle theta. Okay. Suppose this is the circle. This is a sector A OB. That is, suppose this is theta. There is a formula for finding the angle theta in degrees. That is area of this portion. Area of this portion. Area of this portion is, that is A, is equal to theta divided by 360 degree into pi r square. Theta divided by 360 degree into pi r square. This is the area of this sector or the region AOB. Okay. And also length of an arc sector with arc length, this arc length, minor arc AB. Arc length is equal to theta by 360 degree into 2 pi r. This is area, this is the length of the arc. Suppose this is L. This portion is L. Then length of the arc, L is equal to theta divided by 360 into 2 pi r. Okay. Then area of the major sector, pi r square minus area of the minor sector. That can be interchanged. Area of major segment, pi r square minus area of minor segment. Minor segment. What is segment? This portion is called segment. This portion, this shaded region, this is called segment of a circle. This is called segment. This is called segment. Area of the sector, length of the arc. Area of the segment is equal to area of the corresponding sector minus area of the triangle. Area of the triangle with the vertices OAB. We will get the area of this segment. This pink shaded portion, that is called segment of a circle. How we can find out the segment of a circle area? First, we have to find out the area of this sector minus area of this triangle. Triangle means triangle formed by the radii. If we subtract the area of a sector minus area of this triangle, that gives the area of the segment. Area of the segment. Sector of a circle defined, minor arc defined, major arc defined, segment of a circle, the portion of circular region enclosed between a chord and the corresponding arc. Okay. Then you have to by heart these formulas. These are very, very important formulas. 1, 2, 3, 4, 5 formula. In this chapter, these are the important formula. Already we explained it. Okay, these are the important theory parts of this chapter. Okay. Now we are going to do some questions from this chapter. Before that, you have to by heart all these formulas, and some more results you have to by heart for advanced level. Formula for area of a triangle. Formula for area of a triangle. Suppose this is the triangle ABC. This is the triangle ABC. The side opposite to A, suppose this is A, this is B, this is C. Then suppose this angle is theta. This angle is theta. Suppose this angle is theta. Then area of this triangle is half of BC sin theta or half of AB sin C or half of AC sin B. We can use any of this formula. All this formula gives the same result. Okay. This is very important formula. Then another formula. Suppose this is the circle. Suppose this is the circle and center O, radius R, OAB. Okay. Area of triangle OAB. Area of triangle AOB. Formula. Area of triangle AOB. Here also there is a direct formula. Suppose this angle is theta. Then area of this triangle is half into R. That is R square sin theta. Area of triangle AOB is half into R square sin theta. That is very important. Then another formula, some more important results you have to by heart, some more shortcut formulae. Shortcut formulae. This will help you to do problems. Some important shortcut results. Let's. R is the radius of the circle and theta is the angle with the degrees of a sector. Then length of the arc, already we defined it, already we discussed it. Length of the arc of the sector, L denoted as length of the arc of the sector, that is L is equal to theta divided by 360 degree into 2 pi r. What is R? R is the radius of the circle. Theta, the angle in degrees of a sector. And L is the, suppose L is the length of the arc. Then L is equal to theta divided by 360 into 2 pi r. Then perimeter of the circle. Next formula. Perimeter of a perimeter of not circle, perimeter of a sector. Actually, what is a sector? This is a sector. Perimeter means R plus this length of this arc. That is perimeter. Then perimeter is equal to R plus R is 2R plus L. This is L. This is called perimeter of the sector, this portion. That is AOB. OA plus OB plus arc length AB. That is called perimeter of this sector. That is also very important. So this is equal to 2R plus, we can substitute this formula for L. That is theta divided by 360 into 2 pi r. 2 pi r, that is the perimeter. And what is the area of the sector? Area of the sector, this area of this portion. That is called area of the sector. That is equal to theta divided by 360 into pi r square. Theta divided by 360 into pi r square. That is also very important. Then area of the segment. What is the segment? This portion. This portion is the segment. This portion. This is the, not this portion. This portion is the segment of a circle. Okay. Area of this portion is area of this sector minus area of this triangle, that is area of segment, this segment, this pink shaded portion, that is area of the sector, that is already we have, minus area of this triangle. Okay, these are the important formula we discussed, and now we are going to do some questions from this chapter. First question, find the area of a sector. Find the area of a sector of a circle. With radius 6 centimeter. With radius 6 centimeter, if angle of the sector is 60 degree, if angle of the sector is 60 degree. Yes, that is a question. Okay, we have the result. What is the area? Formula for finding the area of a circle, that is area equal to theta divided by 360 into pi r square. Theta divided by 360 degree into pi r square. Then what are the data given that r is equal to 6 centimeter, theta equal to 60 degree. Theta equal to 60. Therefore, A is equal to, you substitute 60 for theta, that is 60 divided by 360 into pi r square. What is pi? Value of pi? Pi is 22 by 7. That is into 22 by 7 into what is r square? 6 into 6. R square is 6 into 6. We can simplify this. 6, 10. That is 6 into 22 by 7. 6 into 22 by 7. That is equal to 132 by 7. All data are in centimeters. So centimeter square. This is the answer. 132 divided by 7 centimeter square. This is the answer. Another question. Find the area. Find the area of a quadrant of a circle. Find the area of a quadrant of a circle whose circumference is 22 centimeter. There are 4 quadrants. That means equally divided into 4 parts. This is one quadrant. This is second. This is third. This is fourth quadrant. Okay, we have to find out the area of one quadrant only. Okay, find the area of the quadrant of circle whose given that circumference is 22 centimeter. So, what is the circumference? Circumference is 2 pi r. That is given that 22. Given as 22. Okay, 2 pi r is equal to 22. There is 2 into 22 by 7 into r is equal to 22. Therefore, what is r? Therefore, r is equal to 22 directly cancel. R equal to 7 by 2 centimeter. That is radius. Radius equal to 7 by 2 centimeter. We have to find out the area of the quadrant. From the adjoining figure, we can observe the quadrant of a circle with what is this angle is 90 degree. That is theta is 90 degree. The angle described by a quadrant, that is at the center, is 90 degree. So area of the quadrant, area of a quadrant. What was our formula? Formula is theta divided by 360 into, this is area of a circle. This is the area of a whole circle. That is, okay, here it is area of only one quadrant. That means 1 by 4 into 1 by 4 of theta divided by 360 into pi r square, that is 1 by 4 into what is theta 90. 90 by 360 into 22 by 7 into 7 by 2 square. Radius is 7 by 2. R square is 7 by 2 square. Okay, simplify this. We can easily simplify this. 90, that is 4 times cancel. Here is 1, 7 will be cancelled, 2 will be cancelled. The remaining terms are 7. After cancelling the terms, we will get 77 by 8 centimeter square. 77 by 8 centimeter square. That is area of one quadrant. So here we have to find out area of only one quadrant. So you take 1 by 4th of this area. This is the area of the whole circle. We have to find out area of only one quadrant. That means 1 by 4th of required area. That is called area of one quadrant. Okay, this is the answer. And another question. You write the question. The length of the minute hand of a clock. The length of the minute hand of a clock is 14 centimeter. Find the area swept by the minute hand. Swept by the minute hand in 5 minutes. Here, given that length of the minute hand, that is R. Length of the minute hand. Actually, that is the radius of the dial or the clock. That is R is equal to, given that it is 14 centimeter. Take R as the length of the minute hand. And what is theta? Suppose theta is the angle traced by the minute hand in 5 minutes. Angle traced by the minute hand in 5 minutes. That is how much? 5 minutes. 5 into 6 degree. 5 into 6 degree. Each consecutive hours 1, 2, 3, etc. This will be 6 degree. That is 30 degree. So, what is theta? Angle traced by the minute hand in 5 minutes. That is 5 into 6 degree. 5 in 5 minutes. In 1 minute is 5. In 2 minutes, 2 into 6 degree. For theta, when it is 5, that is 5. It is given that find the area swept by the minute hand in 5 minutes. So what is the angle theta? Angle theta will be 5 into 60. That is the formula. Then area swept means area of the sector. We have to find out the area of the sector. What is the formula for finding the area of the sector? Theta divided by 360 into pi r square. That is area of the sector. Here theta is equal to how much? 30. This is 30 degree. That is 30 divided by 360 into 22 by 7 into what is r? 14 square. What is r? 14 square. This is the calculation part. Simplify this, you will get 154 by 3 centimeter square. 154 by 3 centimeter square. This part is very important. When convert, how we can convert it? The area, the angle traced by the minute hand in 5 minutes. You always multiply with 6 degree. That is how do you get 5 into 360 degree 360 degree by 60. Actually, this is the idea. 360 by 60 is 6. This is the fundamental formula. So you just multiply with 6 degree. You will get the corresponding angle. If it is 10 degree, you take 10 into 6. If it is for 10 minutes, 10 into 6. If it is 3 minutes, 3 into 6 degree. If it is 4 minutes, 4 into 6 degree. How we get 6 degree? Actually, it is 360 degree by 60. Okay. This is the formula for finding theta when what is 5? Actually, 5 is in 5 minutes. Okay. Actually, actually 1 minute is equal to 360 divided by 60. 1 minute. 1 minute. 1 minute. 2 minute is equal to 360 divided by 6 into 2, etc. Here it is 5 minutes. That is 360 by 60 into 5. That is 6 degree into 5. That is equal to 30 degree. This is the calculation part of theta. Okay. And another question. A chord of a circle of radius, a chord of a circle of radius 10 centimeter. 10 centimeter. Subtends a right angle at the center. Find the area of the corresponding one minor segment. Second part of the question is major sector. Major sector, not segment. First is minor segment, second is major sector. Okay. Suppose this is our circle with the center. This is the center O. These are the radii. This makes angle 90 degree. That is given in the question. That is R radii. That is given as 10 centimeter. 10 centimeter. That is given in the question. Okay. And join this AB. This is the segment part. This is the segment part. And this is the sector part. Okay. Here R is equal to 10. That is given. R is equal to 10. Theta is equal to 90 degree. That is also given.
Then K minus N by K.
Therefore, area of sector. Area of sector. Formula. What is the formula for finding area of sector? That is theta divided by 360 into pi r square. Theta divided by 360 into pi r square. That is 90 divided by 360 into 3.14 into 10 square. We can use the value of pi, that is 3.14 also, no problem. When simplifying this, you will get
Very good morning, children.
78.5 centimeter square. This is area of the sector. Then next is area of triangle AOB. Area of triangle AOB. What is the area of triangle AOB? That is formula 1 by 2 r square sin theta. That is 1 by 2 10 square sin 90. Already from in trigonometry you studied the value of sin 90, that is 1. That is 1 by 2 into 100 into 1. Because sin 90 is 1. That is 50 centimeter square. That is area of triangle OAB. Then area of the minor segment. Therefore, area of minor segment, that is area of the sector minus area of this triangle, that is 78.5 minus 50. Area of the sector minus area of the segment, that is equal to 28.5 centimeter square. This is the first part of the question. First part. Second part, area of the major sector. Area of the major, this part. Area
DC synthetic
of
membrane. അതാണ് blotting.
major
committee.
sector is equal to area of this part. This is the major sector.
തന്നെ പറയുന്നുണ്ട്. Okay, നമ്മുടെ സ്റ്റാൻലി കോക്ക്,
There is what is the total angle of the circle? Area of the circle. Total area of the circle. That is area of the circle minus area of the minor segment. Area of the circle minus area of minor segment. That is the formula. There is, what is the area of the circle? Pi r square. Pi r square minus 78.5. That is, what is pi r square? Pi r square is 3.14 into 10 square minus 78.5. Simplifying this, you will get the final answer is 235.5 centimeter square.
Very good morning.
3.14 into 10 square is, there is 314. 314 minus 78.5 is 235.5 centimeter square. This is the answer. And another question. Another question. You write the question. In a circle of radius 21 centimeter, in a circle of radius
In the sequence from
21 centimeter, an arc subtends an angle of 60 degree. An angle of 60 degree at the center. Find. There are three parts in this question. First part, the length of the arc. Second part, first part, length of the arc. Second part, area of the sector. Area of the sector formed by the arc. Area of the sector formed by the arc. Third part, area of the segment. Area of the segment formed by the corresponding chord. Formed by the corresponding chord. At first, let us draw a figure like this and mark the given data in this figure. Suppose this is the sector. This angle is given as 60 degree. Suppose this is OAB. Join this. This is the segment of the circle. And also given that radius is 21, that is, this is 21. Radius is 21. These data are given in the question. Then, what is the first part? The length of the arc AB. Length of arc AB, that is equal to. What is the formula for length of the arc? That is theta divided by 360 into 2 pi r. This is the formula for finding length of the arc AB. That is, what is theta? 60 degree divided by 360 degree into 2 pi into 21. We can substitute 22 by 7 4 pi. So 60 divided by 360 into 2 into 22 by 7 into 21. You simplify this, you will get some terms are cancelled. Finally, you will get 22 centimeter. This is the first part of the question. 22 centimeter is the answer. For the second part, area of the sector. Area is equal to theta divided by 360 into pi r square. What is theta? 60 divided by 360 into 22 by 7 into 21 into 21 r square. Again simplify this, you will get this is 231 centimeter square. Some terms are cancelled. 231 centimeter square. This is the second part of the question. What is the third part? Area of the segment formed by the corresponding chord. Area of the segment formed by the corresponding chord. So you have to by heart, you have to subtract area of this triangle from area of this sector. For the third part, area is equal to area of triangle. At first you find out area of triangle AOB. Area of triangle AOB is equal to half r square sine theta. Formula half r square sine theta. That is half into 21 square into sine 60. Sine 60. What is sine 60? Half into 441 into root 3 by 2. Sine 60 is root 3 by 2. That is equal to 441 root 3 by 4. Therefore, area is equal to required area. Required area is equal to 231 minus 441 root 3 by 4 centimeter square. This is enough. This is enough. This is the answer. So, area of this segment, that is equal to area of this sector minus area of this triangle. Area of the sector already we have, and area of triangle OAB now we calculate. Right now we calculated. Then subtract the area of the triangle from the area of the sector. That gives the area of the segment also. Okay, that is the answer. This is enough. We can't cancel these terms. This is enough. Another question. Another question. A chord of a circle of radius. A chord of a circle of radius 15 centimeter. 15 centimeter subtends an angle of 60 degree at the center. At the center. Find the areas of the corresponding minor and major segments of the circle. Minor and major segments of the circle. Also given that pi is equal to 3.14, root 3 equal to 1.73. That is also given in the question. Pi is equal to 3.14, root 3 equal to 1.73. Okay, find a chord of a circle of radius 15 centimeter. An angle 60 degree at the center. Okay. Suppose this is the figure. This is the rough figure. Mark the data given. Suppose this is OAB. This is OAB. What is the radii? That is given. Radius is given as, that is 15. This is given as 60 degree. Okay. So area of the minor sector, area of the minor sector, formula. What is the area of the minor sector? That is equal to theta divided by 360 into pi r square. What is theta? 60 divided by 360 into pi into 15 square. Substitute 3.14 for pi. After simplifying, you will get this is equal to 117.75 centimeter square. Substitute 3.14 for pi, that is given in the question. Then area of triangle AOB. Area of triangle AOB. What is the area of triangle AOB? That is equal to half of r square sin theta. That is half of 15 square sin 60. That is half of 225 into root 3 by 2. Substitute 1.73 for root 3. After simplifying, this gives 97.3125 centimeter square. After simplifying, you will get 97.3125 centimeter square. You substitute for root 3, that is 1.73. So we have to find out area of this segment. That is area of the sector minus area of the triangle. What is the area of the minor sector? That is 117.75 minus area of the triangle is 97.3125. Subtract 97.3125 from 117.75. This gives 20.4375 centimeter square. 20.4375 centimeter square. This is the method. Okay, another question. A horse is tied. A horse is tied. A horse is tied to a peg at one corner of a square-shaped grass field offside 15 meter by means of a 5 meter long rope. See figure. Figure is given. Find. There are two parts for the question. First part, the area of that part of the field in which the horse can graze. In which the horse can graze. Second part, the increase in the grazing area if the rope were 10 meter long instead of 5 meter. Use pi is equal to 3.14. So here is the position of the horse. Here this is the horse. Suppose this is the horse. Tied here. Okay. And given that this square 15 meter, 15 meter, 15 meter, 15 meter. And this is given as 5 meter, 5 meter as per question. Therefore, first part, the area of that part of the field in which the horse can graze if the length of the rope is 5 meter. That is actually the area of the quadrant, of a circle of radius 5 meter. Actually, this describes a circle like this. And this is it is only one quadrant. What is its area? Area of this portion, that is half of pi r square. That is half of pi into pi square. That is half of 3.14 into 25. This is the area of this sector. That is 19.625 meter square. That is the area of this part. Area of this part, first part. And second part, if 5 changes to 10, then what will be the increase in grazing area? If 5 increases to 10 meter, then area is equal to 1 by 4 into 3.14 into 10 square. That is 1 by 4 into 3.14 into 100. This gives 78.5 meter square. We have to find out the increasing area. Increasing area means this area minus, that is 78.5 minus 19.625. This is the increasing area. Subtract 19.625 from 78.5. That is given as 58.875 meter square. This is the answer. This is the answer. Okay. Another question. An umbrella has 8 ribs. 8 ribs which are equally spaced. Suppose this is the umbrella, like this. Top of the umbrella, 8 ribs. 8 ribs means 1, 2, 3, 4, 5, 6, 7, 8. 8 ribs. This is the umbrella with 8 ribs. Top of the umbrella. Assuming umbrella to be a flat circle of radius 45 centimeter. Find the area between the 2 consecutive ribs of the umbrella. Suppose this is the umbrella with 8 ribs. Radius is given, that is 45 centimeter. R is equal to 45 centimeter. Then what will be theta? Theta is equal to this angle, that is 360 by 8. 360 by 8, that much angle. 360 by 8 is equal to 45 degree. 360 by 8, that is 45 degree. Okay. Then area of the sector, area of the one sector, this portion. Suppose what will be area of this portion? Area of sector. Formula is theta divided by 360 into pi r square. What is theta? 45. 45 divided by 360 into pi r square, that is 22 by 7 into 45 into 45. Simplifying this, you will get, that is answer 22275. 32275 divided by 28. This is the answer. This is the answer of this question. Another question. A car has two wipers which do not overlap. Each wiper has a blade of length 25 centimeter. Length 25 centimeter. Sweeping through an angle of 115 degree. Find the total area cleaned. Find the total area cleaned at each sweep of the blades. Find the total area cleaned at each sweep of the blades. Okay. First you read the question. Here R is equal to how much? R is equal to given that 25. R is equal to 25 centimeter. The wiper is moving like this. So its hand like this is 25 centimeter, that is given. And it describes an angle. It describes an angle that is 115 degree. So theta is equal to 115 degree. So total area, there are two wipers. For one wiper, we can find out the area. For two wipers, area is equal to 2 times of area of this sector swept by the blade. That is 2 times theta divided by 360 into pi r square. This is the formula for finding the area of the sector. Here 2 wipers are there. So take 2 times of this. So 2 times, what is theta? 115 degree divided by 360 degree into 22 by 7 into 25 square. This gives the answer. Simplifying, you will get a big answer, 158125. 1,58,125 divided by 126 centimeter square. This is the answer. How we take 2 times? Because there are 2 wipers are there, 2 wipers. So we are taking 2 times. Okay, that is very important. Another question. A round table cover has 6 equal designs as shown in the figure. I can draw the figure. A big figure. This is the figure given. This is the figure given. A round table cover has 6 equal designs as shown in the figure. If the radius of the cover is 28 centimeter, if the radius of the cover is 28 centimeter, find the cost of making the designs at the rate of rupees 0.35 per centimeter square. Use root 3 is equal to 1.7. Here is the design. Here is the design. Here, what is the radius is given? 28 centimeter is given. Radius is 28 centimeter. Theta is equal to, total is 360. 360 by 6 parts. 1, 2, 3, 4, 5, 6. That is 60 degree. 60 degree. So, this is the area. This is the sector. This is the figure like. So, what is the area of one design? Area of one design. Similarly, 6 times of one sector. This is the question, 6 times. Area of 6 designs. Area of 6 designs is equal to 6 times area of one design. 6 times area of one design. That is design. This is the design part. That is segments only. Design is only in the segments. That is 6 times area of sector minus area of triangle. That is 6 times area of one sector. That is theta. Theta is 60. 60 divided by 360 into root 3, 60 by 360 into pi, 22 by 7 into pi r square. R is how much? 28. Minus area of one triangle, that is half of r square, 28 square into sin 60. This gives the answer, that is 6 times 60 by 360 into 22 by 7 into 28 square minus 28 square by 2 into sin 60 is root 3 by 2. Substitute 1.74 root 3. Simplify this, you will get the answer. At last, you will get the area of the 6 designs. That means 6 segments. 6 designs means 6 segments. You will get, that is 464.82 that much centimeter square. When simplifying you will get 464.82 centimeter square. Then cost of making the designs at the rate of 0.35. Total cost is equal to how much? Total cost is equal to 0.35 into 464.82. This gives the total cost, that is 162.68 rupees. This is the total cost. It is an application level question. 162.68 rupees. It is an application level question. Okay. Okay, this chapter is, our 11th chapter is almost completed. The difficult questions from NCERT book almost we discussed right now. Okay, thank you children. See you again next class with a new chapter. Thank you all.